Okay, I did want to do a follow-up on this first example using the same data since we already have it loaded in there. Um, Remember that our sample mean on exam 1 was about 43. So the sample mean on exam 1 was about 43%, or 43 out of 50. Now, it was like 42.9 or something like that. So let's say that 43 is now sort of our established number that we got from exam 1, and I'm wondering how exam 2 would compare. Now, technically, that 43 was also based off of a sample, and so if we're comparing information from a sample on one exam to information on a sample from another exam, we should do something that sort of like accounts for the fact that they're both sort of unknown. And that's going to be the next section we look at next week. But for now, I want to use this 43 number that we got from our first exam just as a starting point for a hypothesis test for the second exam. So let's use a hypothesis test to see if there is a difference in the exam 2 mean. You know, different from the 43 we got on exam 1. Now again, technically what we should be doing is doing some sort of like compare the two means hypothesis test that accounts for the fact that this 43 is itself a guess. And we're going to do that in the next section. But I wanted to have an example where I could do a hypothesis test with one proportion. So we're just going to use this 43 as an excuse to have an example for a hypothesis test. So we should have a testing level. Let's test at 5%. And we also need an alternative hypothesis. We'll use not equal as our alternative hypothesis, HA. Okay, because I don't know if exam 2, I have no reason to expect it to be higher or lower. You know, the way that calculus runs, usually the stuff that you cover in the first 3 weeks is a little bit easier than the stuff that comes right after that. But the really hard exam is the third exam. So at least when I teach it with 4 exams. So I don't know whether it would be higher or lower, and our default choice is not equals anyway. So using the exam 2 data, let's run a hypothesis test comparing the exam 2 mean to 43. The reason we're comparing to 43 is that that's the number we got before. Okay, so let's flip over to Minitab and run that hypothesis test. Okay, so in Minitab, we do stat, basic statistics, one sample T, and I'm no longer using exam 1. Let's get rid of that. Now I'm using the data from exam 2. I want to perform a hypothesis test, and the number I'm comparing to is 43, which isn't even exactly the number I got in exam 1. This is our number from exam 1, 42.911, but we're going to compare to 43 just to practice running a hypothesis test. In options, my alternative hypothesis has a not equals like it should, and we may as well still make a histogram. We can see the histogram for exam 2. Okay, so let's see what we get then. All right, our confidence interval for exam 2 is in the upper 30s, and it was in the lower 40s for exam 1. So the mean on this one was a lot lower. We went from a 43 down to like a 37. And even when you take into account the confidence interval, it's in the 30s instead of the 40s. So it looks like our p-value is really small. Exam 2 is definitely much worse. Yeah, our p-value is like 6 zeros before we finally get something. It's a 6 in the 7th decimal place. That's very strong evidence that the students did much worse on exam 2. So for some reason, that exam was much harder for them. So here's the null hypothesis number we're comparing to. Here's the sample mean that we got and the confidence interval, and you can see that the number we're comparing to is well outside of our confidence interval. So yeah, so exam 2 was much tougher here. And you can see on the histogram that like before people were sort of stacked up here in the high 40s. Now it's like there's a few in the high 40s, but there's beyond those people, there's sort of like a bell that's centered around the upper 30s. So definitely much harder on exam 2. All right, so I think that's enough for this example. We have strong evidence that the exam 2 mean is not the same as the exam 1 mean, and it looks like it was much harder.